All right, so like Patrick said, a lot of what we're going to go over today is like originally an 8-hour tutorial that we've condensed into 25 minutes. So we're going to go very quickly. We will try to answer as many questions as you can, but we're also going to keep it going so that you can get to every single presenter that's going to share something with you today. So Melanie and I are going to go over the OMOP CDM, the vocabulary, and then walk you through some ETL best practices. So here's what we've got for our agenda. I'm going to go through 25 minutes of the CDM and vocabulary. Melanie's going to take you through ETL. You're going to have a quick energy break. When we come back, Melanie's going to do an ETL exercise for you looking at farm metrics. So we did send out a little scan report and an email on Thursday. So if you haven't checked your email, just check it because you will have an opportunity to walk through that with us if you so choose. And then after that, I'm just going to take you quickly through a vocabulary exercise where we're going to be looking at how do we identify those concepts that Patrick was talking about, specifically lisinopril and angioedema. So here we are. That's me and our newest data standards titan, Melanie. So pretty sure you know us, but I wanted to put that up there anyway. All right, so if you have not had these bookmarked before, I strongly recommend you do that. Even if you are not an ETL person or you don't consider yourself the data standards person in your institution, I find that these resources are extremely valuable. The GitHub for the Common Data Model, a couple years ago, we totally revamped this, and all of our documentation is up there for every single version of the CDM that we are currently supporting. So it's a highly valuable resource. I strongly recommend you going out there. We've got information on conventions, on every table and field, and because this is so condensed, you're going to need this resource because I can't go through it all with you today, nor would you want me to. It'd be really boring. And then we've also got Athena. Athena is our open source website. You can just go through there and start navigating the vocabulary. We're going to use it a little bit later. I'll show you how it will be helpful for you to start to identify concepts. It's also where you would download the vocabulary if you want to do that. Some vocabularies require licenses, but almost everything that you would need to get started, you can just go out and download on your own. Unfortunately, my computer decided not to play today, but I've actually done this myself. I have just a local environment where I've downloaded just the general vocabularies where I can just play around in just a little Postgres environment, and it's actually very helpful. So if you want to do that, go ahead and go out there, but we're really going to be using the user interface today. All right, so I'm a little irritated with Patrick, and I got to tell you why. He didn't tell me he was going to use a Lego example yesterday. So I have this cool train example that I put together actually like 2 years ago. I don't know if you remember this, Patrick. I was going to give a presentation to the FDA BEST folks, and I had this like really cool example. I was like, "Oh, it's like a train, man." And he was like, "No, you got to take it out. You can't show that to them." So I decided to revive it. But if I'd have known, I would have used a Lego example. So I'm bringing it back for you guys because I think it's really cool and I really like it. So you heard from Patrick yesterday, though, all jokes aside. You heard from him how OHDSI we're a series of building blocks and we're all working together. One of those is the CDM. If I also think about it kind of as a train where the tracks are the data model and our methods, our evidence, everything we're doing sits on top of that data model, and it's all got to run smoothly. But I don't know if you know this, so I'm going to delve into a little bit of like US history. Early on, around like early 1800s, as trains were beginning to become more popular, the steam engine, everything was going great. There were all these different companies building train tracks and stations around the US. But every company had a different train gauge, meaning the width of the tracks. And they would have train cars specifically for that train gauge. But if you got to a space where the gauge would break, meaning the train couldn't run on the next track, you would actually have to either lift up the train and move it to a different track, which you can imagine is highly difficult and complicated and expensive, Or, which I think this is a really good analogy for what was happening prior to, OHDSI and the common data model, they would literally have to take every single thing off of the train and put it on a new train, which is also expensive, difficult. You might lose things, people get misplaced, and it's just very difficult and time consuming. So that's kind of why I think of it as the common data model as a train, because now we've got this track. We're not breaking gauge anywhere. You don't have to, write a whole new series of packages and codes just to run one study on 1 or 2 databases. Now we have a study that we're running on 27 different databases, all because we're running on the same gauge. We're all on the same track. We're all using the same building block. So to me, that's really like a powerful example of why this is so important. You also saw yesterday, George shared this with you a little bit, but I think this example is also extremely demonstrative of why the CDM is so beneficial. So this is our new community dashboard, and you can see just over time, the number of publications has grown exponentially, and the number of researchers and community members like yourself have grown exponentially. And none of that would be possible without a strong, solid foundation, without those building blocks, without that train running smoothly on the tracks. All right, so I came up with this definition. It's my own kind of wordsmithing here, but I think it's helpful because a lot of times we think of the CDM as the tables or the vocabulary. But I would put it to you that the OMOP Common Data Model is the entirety. It's the tables, the vocabularies, and our standard conventions that allow these data to be standardized, that facilitates our rapid innovation that you're going to see today. All right, and one more shameful example, but I'd like to bring in theology a little bit too. The CDM to me, it holds everything up. We're holding up our standard analytics, our open source development, our methods research. And unlike in Greek mythology where Atlas was actually punished because he has to hold up the heavens, if you ask anybody in our working group, I really see this as an honor. I take this very seriously. The Common Data Model is the foundation of everything we do in OHDSI, and anything that we do in the Common Data Model working group extends outward to the entire community. So it's not just, I sometimes feel like some people are like, oh, it's just a data model. It's not just a data model. It's the entire foundation, and it's extremely important, and I am very honored and excited to be here to tell you about it. All right, so let's get into it. You're probably tired of me. Okay, yeah, we know it's important. All right, so yeah, get on with it. All right, so you've seen this slide many times. I'm sure most of you know what's going on here. The blue boxes are the actual tables that hold the data. You've got the standardized vocabularies there in the orange boxes. And I put a little heart because they're like best friends. You can't have one without the other. They snuggle up, like they're interlinked. You can't, if you had the tables and you had all your data in the tables, but say, you didn't want to use the standard vocabularies, well, you wasted your time. You got to have both. You can't run all these cool things and network analyses and cohort diagnostics and patient level prediction without the two. So I'm actually going to talk to you a little bit about the vocabularies before I talk to you about the model itself. Because I find as I talk to folks, the vocabulary is the most difficult portion to really wrap your head around. So I want to start there just quickly, and then I'll just take you through a couple of things about the tables. All right, so I'm not going to take you through the entire vocabulary schema. Again, that would be really boring, but it is important to know all the tables that go into it. So the main table is the concept table. And as we work through our small example today, we'll be talking and looking at the concept table. The concept ancestor table we're going to be looking at because that's really where a lot of the power of the vocabularies come into play. Those hierarchies that we use are very, very valuable, and you'll see that when we do our example looking at lisinopril, how we can quickly identify all drugs that have that one ingredient just by running a simple query. So concept ancestor are going to be really important. And then if you are an ETL person, if that's your role at your institution, concept relationship is also going to be really important, because that's the table that says you have a non-standard concept, you've got an ICD-9, you've got an NDC, you've got an ICPC code like Tom Sinan talked about yesterday. And that concept relationship table is going to tell you this non-standard code you have in your data set, this is what it maps to in the standard vocabulary. So that one's also extremely important. The other ones are very important as well, but we're not going to get into those today. You can look at them on the website like I showed you, and there's a lot of information on the Eden Academy about the vocabularies too. Couple different categories of concepts, like I was saying. So we've got the non-standard concepts, your standard concepts, and then your classification concepts. Everything we do in OHDSI is going to be focused on the standard concepts, because that's exactly the point. We're standardizing our data. Everybody's going to be using the exact same concepts in the exact same tables. So every single study package that you run is going to know exactly where to look for that one particular concept in your instance of the CDM. Now, the non-standard concepts are also really important. So you'll notice every non-standard code, so non-standard would be the codes really as they exist in your data. So that would be those ICD-9s, the ICPCs, the NDCs. As we incorporate them into the OMOP vocabulary, we actually give them their own concept. Even though they're not standard, it's really, really important that we do that. I've had a couple people ask me why. They're like, well, you know, it's just an ICD-9. Like, why do you have to give it your own identifier? Well, if you actually go into Athena and you look at all those vocabularies, I don't know how many we have. We have over, I want to say like 80 to 100 different vocabularies that have actually been incorporated and mapped to standard concepts. And you can't tell me that of all those 80 vocabularies, they're all going to be unique codes and identifiers. They're just not. So what we do is we bring them in, we give them their own unique OMOP identifier or concept ID, and then we can use that concept relationship table to map them to standard concepts, which is really where we all want to be. We all need to be at that standard concept level. And then we also have some classification concepts. We're not going to really go into those, but you'll see them in the vocabulary. For the SQL heads out there, it'd be where standard concept equals C. And those just help us with some classifications. We have some drug hierarchies and some condition hierarchies in there. Right. So again, like I was saying, if your source data codes are in the vocab, you can use that to translate to a standard, and you would use the concept relationship table to do that. All right, I'm going to go quick here. There's also, if you wanted to just explore a query that does that for you, it's on the website. If you go to odyssey.github.io/common data model, we have some helpful SQL scripts out there. And you'll see in that source to standard SQL script, it'll actually has a full query for you that would allow you to play with it and see how you would map source codes to standard concepts. So you don't have to do it alone. All right, so I've only got about 5 minutes left, so I'm going to go quick. On the OMOP CDM, it is a person-centric model. If there's one thing you need to know about the OMOP CDM, it is person-centric. As Patrick said yesterday, what we're trying to do is associate clinical facts to a person. Now, the structure of the CDM is really so that we know where those facts are going to go, we know where to find them, and the vocabulary says, hey, I see that you had a condition, you should put this clinical fact in the condition table. Well, that's all we're really trying to do, is we're just trying to say, okay, for everyone around the world, if I know that you have angioedema, I will find it with the same concept ID in the same place. But we're just trying to find out what clinical facts should be related to an individual person. That's all it is. And then we're just putting them all in the same place so we can run open source development, standard analytics, and generate evidence at large scale. Really quickly, this is an example of what you would see on the website. So I've got a link down there. If you go in and you click on CDM version 5.4, which is our latest CDM version, you'll see there's listings for every single table. And every single table will have a description telling you what should be in this table. Gives you a user guide. So if you're just using the CDM, maybe you're not ETLing it, but you want to understand what would I expect to see in this table. That's what that user guide would be. And then there's some ETL conventions in there. So you would know maybe how was this table put together? Even if you weren't involved in the ETL, you know a little bit about what went into it. And then there's going to be that same information for every field in that table. So really, for the CDM, the only tables we mandate that you have are person and observation period. The person is just going to be, here's the people in my data, here's who I have. Observation period is really important from an epidemiological perspective because we need to know at what time period can I expect to find clinical facts for a person. Now, in relation to pharmetrics, U.S. administrative claims, that does require an enrollment. So you have to enroll in a health plan to be covered by that insurance. So in that case, your observation period would be the time you're enrolled in that insurance. A lot of our colleagues, so I'm talking about Tom Synan a lot because I work with Peter Reinbeck, and in the Netherlands, you have to register with a GP. Similar to the UK, if you guys are familiar with the clinical practice research data link data set, you have to register with a GP. In that case, the dates you are registered with a GP, that would become your observation period. So what we're really trying to identify is who are you and at what time frame can I expect to find clinical information for you. Apart from that, you would really just fill out the tables in the CDM as the vocabulary dictates based on the clinical facts you have available. And you'll find in every table, we try to make it, again, pretty standardized. So in almost every clinical fact table, you'll find an ID. The ID is really just the unique identifier for that clinical fact. So if it's a condition, it would be the condition occurrence ID. If it's a measurement, it's a measurement ID, and so on and so forth. Then you've got your concept ID, which would be the standard concept representing that clinical fact. But we also keep the source concept ID and the source value. So in the case of angioedema, you might have an ICD-10 code that represents angioedema. That would go in the source value field. And then you've got your source concept ID that is like the OMOP vocabulary identifier for that particular ICD-10 code. And like I keep saying, but the domain of the concept, so that standard concept for angioedema, whatever domain is listed for it in the vocabulary, that is where it should go in the CDM table. So again, take a look around the websites. You'll see what I mean as you start walking through it, but it's really just a quick overview of how this would go. So if you want to know a little bit more about these conventions and all these different fields that you would find in every clinical fact table, we do have it in the data model conventions, that little document on the website. So if you, I think it's under like general conventions, and then there'll be data model conventions. So you can read about this. And we have tried to be very helpful. So as you go through the documentation, you'll see links. So if, for example, in the drug exposure table, it says clinical facts or records where the concept has a domain of drugs should go here. And it'll actually link you out to Athena to tell you, here are those concepts with a domain of drug. Similarly, it'll link you out to approved gender concepts, race concepts, all those kind of things. So we try to make it very clear as to how the CDM and the vocabulary relate to one another. Okay, I am right on time. I made up. Any questions before I hand it over to Melanie? Okay, I got one in the back. You're going to have to talk loud. Not yet, but they will be after the tutorial, I think. Right, Patrick? Yeah. Yeah, they will be after the tutorial. And if you are a member of the teams for the Common Data Model team, you would already see these files on the team's interface. Otherwise, we will send them out after the tutorial. All right, I'm gonna hand it over to Melanie.
All right, thank you, Claire. So I'm going to do a quick overview here of the ETL process and the tools at a high level. So you're all familiarized with the process. After I go through this portion, we're going to take a quick break, and when we come back, we're going to do a hands-on exercise where we review each tool's purpose, usage, and output a little bit deeper. So the three tools we're going to be talking about today are the White Rabbit tool, Rabbit in a Hat, and Usagi. So this is your general, what we do for extract, transform, and load, or ETL. We go from our raw source data into the OMOP CDM. So we need to design and develop an ETL process. All these tools are out there on GitHub with their appropriate documentation. And once we get it, this is the hard part, right? This is the ETL, taking your source data, getting it into the CDM. And once you have it in the CDM, then you get to do the fun thing. Then you get to do the research. So in our book of Odyssey, we talk about the ETL process in chapter 6, and this is available on GitHub also. Everything's available on GitHub. You can also order a copy of this on Amazon if you want. So here's a general overview of the ETL process. We start off with the data experts and the CDM experts who design the ETL. Then people with medical knowledge create the code mappings. As you can see down on the bottom, the first step here with the data experts and CDM experts, you can use the White Rabbit and Rabbit in a Hat tool. People with medical knowledge create the code mapping. So if you have any type of custom codes or string text that you need to map to the CDM, you can use the Usagi tool. Otherwise, if you have an OMOP supported vocabulary, you will download those vocabularies with their mappings from the Athena website. Then we also use White Rabbit and Rabbit in a Hat to design the ETL. It produces documentation. These two tools do not produce your SQL code, but they do produce the document. It's a conceptual logic. Then you have a technical person implement the ETL, so they'll write the SQL and then implement it into your tables. And then everybody's involved in quality control. And we use Achilles and DQD for that. So we're going to start off with the CDM and data experts designing the ETL, and the first tool is Rabbit in a Hat. White Rabbit scans your source data and creates a CSV giving you summarized statistics of the data. It helps you learn a little bit more about your source data and design your ETL. And that scan report you upload into Rabbit in the Hat where you actually do the mappings. If you have a really large data set with multiple tables and potentially hundreds of fields like you have with like EHR data, you'll want to pare it down a little bit and stage it before running White Rabbit. So this is what the White Rabbit report output looks like. This is a scan report. So you can see two examples. You have a table and field overview. Those are two tabs within the scan report. And then another tab will drill down a little bit deeper, more granular, and actually give you the different fields with the values in it and the frequency counts for those values. Rabbit in a Hat. We upload the White Rabbit scan into Rabbit in a Hat, and it provides a graphical user interface so you can map table to table and field to field within that, and it's really easy. You just drag and drop your arrows as you go through, and this user interface also allows you to drill down into each of your source tables and into the CDM table. So if you're not quite sure how you're going to map your data, you can take a look at each of those fields and tables and the conventions about them. And then Rabbit in a Hat gives you three different types of output. It gives you a Word document. A lot of times these are commonly referred to as specifications. And you'll see that we have some of those mappings right there along with the document. It also provides an HTML and Markdown documents can be generated from Rabbit in a Hat. Then once we have all these documents, we're going to do some custom mapping with the USAGI. So we need people with medical knowledge to really truly know what the meanings of some of these string texts and descriptions are. So you only need to use USAGI when you have a vocabulary that is not supported by OMOP and OHDSI. And a lot of times we'll find this kind of data like in your flow sheets for vital signs. It'll just say something like heart rate or, cigarette smoker. And USAGI helps you find the best matches via a search function. It uses TF-IDF, which is a term frequency, inverse document frequency, which is just a text-based recommender system. And you're able to search, narrow down your search. You can do it by domain, by vocabulary and stuff to give you closest matches. All right, so here's an overview of steps for USAGI because we're not going to go into this during the exercise. So you get a copy of your vocabulary from Athena, then you download the USAGI tool, and then you have USAGI build an index on the vocabulary. This is a one-time setup, and then from here you can use it multiple times to map multiple domains. You load all your source codes and you let USAGI process them, and they will give different match scores. So if it's an exact match, you'll get a 1.0, which is great. And if it's not, you'll get another number. So you review and update any suggested mappings with someone who has medical knowledge. So those 1.0s are pretty easy wins. Once you start getting down into the 0.7, 0.6, 0.5, you might want to take a closer look at those and maybe suggest a different mapping. And then once you're done and you have approved all the mappings, you can export these codes into a source to concept map table. It downloads it into a CSV, at which time you can have somebody put it into the source to concept map table, and your ETL would use these mappings along with the OMOP provided concepts and concept relationships. Technical person implements the ETL. And so there are multiple tools available to help you implement your ETL. You can do it in R, you can do it in Python. A lot of people do it in SQL. Your choice will largely depend on the size and complexity of your ETL design and also the tools that you have available to you at your institution. So the general flow of implementation looks like this. As Claire is saying, the person is the center of the data model. So we always start with the person table. Along with that, we can also add in the other dimension tables like provider, care site, locations. And then you have to upload your visit occurrence because all your clinical events reference your visit occurrence, your person in those other dimension tables. Then you implement all your clinical event tables, conditions, observation, drugs, procedures. And then there's the observation period table. And this you need, very important. Some people derive this is a derive table from your data. Some folks derive it from the visit occurrence table, and some other places derive it from all their clinical events. So you either implement it along with your visit occurrence, or you implement it once you have inserted all your data into the CDM, all your clinical event data. We have a few tools out there for data quality, but everybody is involved in the data quality process just because data quality issues can arise at any step during the ETL process. You can have duplicate data at the source, you can have SQL bugs, you can have a technical implementation mishap, and there will be bugs. It's not a big deal, it's just something you need to run your data quality checks and resolve. So we have 3 different tools available out there on the OHDSI GitHub to help you with this. Rabbit in the Hat creates a test case framework for you. This is a set of unit tests using R. Achilles displays summarized statistics of your data. And so that's helpful to look at. It'll display for you, just a graph of the ages. So if you have a pediatric data set and you see a large spike of people 80 or 85 years old, there might be something wrong with your ETL. And then we have the data quality dashboard. And And this is a great tool. There are over 3,400 checks within the data quality dashboard, and it checks plausibility, conformance to the conventions and the data model standards. Really great tool. So the unit test cases, very important to test your ETL because it's very complex. The more tables you bring in, the more data sources you bring in, you can easily make a mistake and it may go unnoticed. So it's definitely important to do unit test cases. Also, your source data is going to update. The CDM model is going to update. Your source data is probably going to update a lot quicker than the CDM model. So you want to make sure you're on top of all of those changes. And Rabbit in a Hat can construct some of these unit tests for you. These are little pieces of code that check small parts of your ETL to make sure it was properly ETL'd. Achilles is used for data characterization and generates some summary statistics describing the quality and content of your CDM. And these are available for download right here. If you want to see some sample data, that R script is located down there. The bottom. And the data quality dashboard. This is based on the Con data quality framework, and it runs over 3,400 data quality checks. And this nice overview right here gives you a general overview of your passes and your fails. Your metadata just tells you about your CDM, what version of the vocabulary you're on, things like that, what date your data is from, when this data quality was run. And then in the results tab, you're able to drill down to each of these checks. It's kind of like a CSV, and you could click on that first tab and you can check everything that's failed. I usually just skip the things that passed. It's great, it passed. I'm more interested in the things that failed. So you can really drill down. It even has the SQL that was used for that check, for the data quality check. So that way you could take that SQL snippet and run it against your actual source tables to take a closer look at that. All right, I ran through my portion very quickly. We're going to take a quick 10-minute energy break, and then when we get back, I want everybody to open up that scan report that we sent on Thursday, because we're going to be working through that in the next session. And then also, if you have White Rabbit, Rabbit in a Hat, we'll do that. But first, I want to take questions.
Yeah, I didn't get the email.
Claire is going to send that email out again right now. So she's just going to CC everybody that is registered for this tutorial. Does anybody have any other questions about data quality tools, the ETL tools? All right, let's take a quick break. And then if you do have questions, you can come up and ask us. We're here.
Oh yeah, it was more about that. Yeah.
Can we somewhere where they won't go down?
But also sometimes represent the data markets because they're tough.
I think so.
No, we're doing it.
Okay. All right. And then I'll just hang on the slides. Yeah.
Try that, but it's tough.
Oh, no, yeah,
So
no.
it did get some help from some of the markets, but most of them don't really have it. We have in-house IDs. So we do have technical expertise. Probably should talk to them.
Technical difficulty with that email. You can find it here out on GitHub. Odyssey Common Data Model Tree Tutorial Extras. So navigate to that and you can download the White Rabbit scan report. I'll give everybody a minute to Show of hands of who's been able to get that downloaded.
Still logging in.
All right.
Oh, there we go.
Do folks have that now? There's no username and password to it? It's all open.
Is it you want a case sensitive? I think it is.
Yes, it is, yeah.
So if you want it as case sensitive, if you see an error message, maybe your case is not right.
If you if you go to the link I sent you before, just to the documentation, there's like a little like GitHub icon in the top right-hand corner that'll take you directly to the repository. You would just need to go to the tutorial. Okay, so if you go to that documentation website that I sent you earlier, github.io/common data model, there's a little cat icon, GitHub icon, in the top right corner that'll take you directly to the repository. And then you just need to go to the tutorial branch in extras to find the document. Sorry. I didn't have everybody's email addresses, so this felt like the easiest thing to do. You guys finding it? Yes, I'm hearing yeses. Okay.
So you're not connecting?
Okay.
I have a question. So after we get into the GitHub, what should we do now?
Then you go to the tutorial branch, so you'll see it says main. Oh yes, so it's the scan report right here, the little Excel file. Yes, you want the one that says Odyssey sample scan report. I kind of just hijacked my GitHub for a little bit.
All right, sounds like most people have found that scan report now. Yes, if you are having trouble navigate, just raise your hand. Claire will come around. We also have Gautam and a couple other folks that will help out. Yeah, Oz is back there. So, all right. So we're going to review the White Rabbit tool and scan report. Then I'm going to demo the rabbit in a hat. And then I'm going to have you guys do a quick exercise, taking that scan report and doing a quick little mapping using Rabbit in the Hat. If you don't have Rabbit in the Hat installed, you can work with a neighbor over their shoulder, or you can just spend more time reviewing the scan report. Right. So once you open up White Rabbit, you set the location of your data. White Rabbit can take many different types of files. It can be the text delimited files, SAS files, MS SQL, and there's a handful. Yes?
How to download White Rabbit?
How do you download White Rabbit?
It is at, Claire probably knows the URL link.
It's I'm so sorry. I thought we had it all in an email and I just didn't get to everybody. So for White Rabbit, it would be github.com/odyssey. So if you just go there and search White Rabbit, that repository, the latest release will get you White Rabbit and Rabbit in a Hat. Can you go to the website?
I am going to pull up the website right now.
Awesome.
So I actually just Google this every time I don't have a link. I just write in Odyssey GitHub. Pick any of these, Odyssey GitHub Atlas. Click on Odyssey. And then under repositories, then you type in White Rabbit and it will get you over there. Slowly but surely. Sorry that email didn't get out to everybody. Click on White Rabbit.
Yeah, so White Rabbit, that repository, if you go, can you click on releases over in the corner, Melanie? Like release version 10.7 down on the right-hand side, right down there. Yeah, so if you click there, if you download, you'll get both White Rabbit and Rabbit in a Hat for Mac and Windows OS.
You have?
I've tried it and used it. I did too. I did the same thing, it's not just you. Yeah.
And we have a rate limit for GitHub users.
Oh, okay, got it. All right.
Probably the hospital's Wi-Fi IP address.
Yeah, IP address and all that.
And so some of you might have this blocked and be unable to download things off the internet on your specific device based on your institution's privacy and security measures.
You shouldn't have to install it. You should just run it.
So you just download the zip file and then you'll open it up and you'll just run Rabbit in a Hat.
It's right after working hours there, so.
All right, if you're having any problems, just raise your hand and somebody will come by to help you out. Yeah.
Only download White Rabbit and Rabbit in a Hat if you really want to work with this today. You don't have to. Melanie will be going through how it works. As long as you have the scan report, you'll be able to see information about farm metrics and data set we're working with in that scan report. So Rabbit in a Hat and White Rabbit creates the scan report. Rabbit in a Hat is the visual medium to map the ETL. So even if you don't have it, you will not be lost today. You will be okay.
Yeah, I'm going to go over everything. So. All right, so you're actually not going to do the scan using White Rabbit. You're not going to scan any of your data. I'm just going to show you how you would scan your data. But then we're going to take that scan report that you downloaded from the GitHub, and then we're going to run it through Rabbit in a Hat. So you set your location of your data. It can work with many different types of data files, whether it's a text delimited, a SAS file, you know, a few handfuls of the different types of SQL out there. And then you set your different attributes, your server location, username, password, and so on. Then for the actual scan, you're going to want to select which tables you want to scan. And you'll see that's empty right now, but you would have some there. And then you click on them and you add them. Because you may not want to scan every single table in your database, especially if you have EHR data. That's a lot of tables. And then here you can set some... you can limit the size of the scan results. It'll just make that CSV a lot easier to work with. So White Rabbit outputs a CSV, and here I have set the rows per table to 100,000. So it'll scan 100,000 rows in each of my tables, and it will limit the number of distinct values to 1,000. That's a lot of distinct values to be looking at. And then also I set a minimum cell count to 5. So that way, if you have any values that have a count less than 5, they will not be displayed. Some folks might want to do this because if you're using like an MRN in part of your scan report, then maybe you don't want to display that because maybe you want to send the scan report around to other folks that may not have that level of access to the data. And it also eliminates that really long table that we sometimes have with our data because we just have 1s and 2s of certain values. All right, so let's open up the scan report. I'm going to open up the scan report on my laptop. Okay, so let's make this a little larger.
Melanie, just one administrative housekeeping item.
Housekeeping, yes, let's do housekeeping.
If everybody goes to odyssey.org
and you go to the 2022 symposium page, you're now going to see a drop down that says scan report. So if you want to go get this file, you now can.
Thank you. I kind of bootlegged my GitHub a little bit.
Okay, so they're getting it there?
Yeah.
But yeah, if you can't get there, you just go to odyssey.org, drop down to 2022 symposium, go to the tutorial, and it'll pop up. It says scan report. And then you're going to see a whole bunch of drop downs that'll pop up for all of the lectures.
All right, thank you, Patrick.
Yeah.
All right, so when you open up your White Rabbit scan report, you will see that you will open it up to the second tab, and this is the table overview. So in column A has all the table names. Column B is description. Now this does not come from your source data. This is something we can add in. So I know that the POP table is actually the patient table. So I'll add this in. And then this next one is diagnoses. And when you add these in, these will now be displayed in Rabbit in a Hat. So you can add the descriptions in. It will be a little bit helpful to when you're mapping, especially when your table names are acronyms or maybe they're possibly in a foreign language or you need a little bit more information. In rows is the number of rows that are in that table. So about 16 million for the population table. Number of rows checked, we limited this when we did our original White Rabbit scan on our source data. We limited it to 100,000, so that's how many rows it checked. In fields is the number of fields in that table. So for the POP table, that would be 15 fields, and 2 of those fields are empty. As you'll see down here in this line, number 6, claims, that actually didn't check any rows. So that's something we might want to take a look at and troubleshoot what's going on there. If we go to the field overview tab, whoops. I'm going to make this a little bit bigger. Column A gives you the name of your table. So that first set of is POP, and that's our patient table. Then we have the fields. So this displays column B displays all the fields that are in the population table. Column C is description. This is just like the table description. This is something we add in, and that is not part of our White Rabbit scan report. So dir_sex is a person's sex. dir_YOB is year of birth. So we just add these values in and we save them. So we'll be able to view them in Rabbit in a Hat. Column D gives us our data type. So there's a lot of different data types coming from the source. We have character, double precision, big int. We have some dates down here for these date fields. The max length is the max length of the values in that field. In rows, number of rows for that field in the table. Just like we thought, rows checked 100,000, and that was part of our delimiting that we did for White Rabbit before we checked it. Fraction empty, this is really important. How many of these values are null? So for sex, it's none, that's great. And there's 3 different unique values. So male, female, and some other value coming from our source, and fraction unique. So down here, we do see that there's about 23% of this non-IMS PAT ID is null. So we have a couple different fields that we can use for a patient identifier coming from our source data. We have PAT ID, we have PAT hash ID, and then the non-PAT ID. So this, so far, for the 100,000 rows that it scanned, none of them are empty. None of them are null. And you need to have a patient ID so that way you can link your data records, your person, to your clinical events.
Can I ask you a question about that?
Yes.
Can you define empty, or does empty mean null? You know, like the concept ID 0 in the condition occurrence table or something? If your source data defines it like that, can you define it here?
So concept ID 0 actually means no matching concept.
It just reads what's in your data. So you wouldn't define it here. It will just tell you, oh, there's a null or a blank. It's just going to tell you what's in there. You're not doing anything for the ETL really in the scan report. It's just saying, here's what you got.
You know the description, can you put whatever you want there, or does that have to be a specific way of writing so
So with the description, no, it just needs to be any type of string text. You can put whatever works for you and your team best in there. Yep, that's for you to play around with, and Rabbit in a Hat is just going to display this for you. Any other questions? All right, let's drill down to the table a little bit further. So this is the POP table. And in the table level, you'll see that all of the columns are paired up, right? So column A and column B go together, C and D go together. So in column A, it's the dir underscore sex, and we see those three values that we were told about in the field overview. So the first one is F for female. It's just over 50,000 people. M for male, which is just under 50,000 people. And then we have 7 with an unknown or a U value. So if the CDM says you're either male or female, so you would have to try to find, you wouldn't be able to map these to a standard concept, but that's okay. You might be able to pull this data from somewhere else. I put these filters in because I like to take a look at some of these values, especially things like year of birth. So if we take a look at this, we will see that there are some values are 0.0. Your year of birth is a required field in the CDM. You don't need to have a day of birth or a month of birth, but you have to have a year. So we see that occurs actually 925 out of our 100,000. That's less than 1%. So you could either toss out these patient records, or you could try to find some type of proxy. Maybe there's another table with a field called age, and that way you could derive the person's year of birth. Clear that filter out. Column E has our PAT ID. So we said any value that has a frequency less than 5 not to display, and that's what list truncated means. So you'll see that at a couple places. PAT ID, PAT hash ID, those were all unique. So there is only one there's only one record for each value, so the list was truncated here. You can change your settings in the White Rabbit tool before you scan it if you wanted to display all of those. And then here's the different other fields that we will see in the POP table. We have things like patient region, patient state, patient zip 3, that's the 3-code zip, and so on. Now I'm going to open up the Rabbit in a Hat tool, and I'm going to show you how we import the scan. All right, so when you open up Rabbit in a Hat, you'll see that CDM version 5.4 is already populated, and this is the CDM version that the Odyssey community is on right now. We toggle over to File, and we are going to open our scan report. So the White Rabbit scan report populates right into the tool. And now we can see all of our source tables are here in orange. All of our CDM tables are in purple. Really easy tool to use. You can just drag and drop. So we want to go from POP table to the CDM person table. If you wanted to find out, oh, I forget what that POP table is, what it's all about, you can double click on it. It's going to give you your table name, which is POP, the number of rows, and then the description. So the description we filled in on that White Rabbit scan report is now populated here. So we see it's patient, and I spelled patient incorrectly. So there's that. You can see over here on the left-hand side, we have all of the fields that are in our source table. And then over here gives us a little bit more information. It displays our data type for each of these fields, and then any description that we gave it. So click back on population, and it brings us back to the table level. So a very good practice to always do is you always start at your table level mapping. So you map things over. We know that the claims goes over to the condition occurrence. And then you would just map these over like this. There's a couple different, as I talked about earlier, there's 3 different documents that you can generate from this report once you have all your mappings done. You can have that Word document, which is the specifications, an HTML document, and a Markdown document. This does not produce the SQL needed to convert your data, though. So you would use these documents, right? This is a conceptual logic that your SQL developer will then write the SQL off of that conceptual logic. We can click on that particular linkage right here between POP and person, and then this is going to give us all our source fields. So now we can drill down to the next level. Now that we've mapped our table, we're going to map our source fields to our OMOP CDM fields. So dir_sex, we could click on that. It's going to let us know that this is the name of the field, and this is the description we gave it, sex. These are the values along with their frequency and the percentage that they make up. So the females just over half, males just under half, and then, well, less than 1%, those 7 extra values of the unknown. So you take these and you just drag and drop once again. Sex goes to the gender concept ID. And then there's actually a gender source value down at the very bottom of the screen. So we can drag and drop that. And then we do that for each of our different fields, year of birth, and so on. Now, not every table and every field in your source data has to go to the OMOP CDM. As Claire was saying earlier, you have to have a person, they have to have a year of birth. And there's a couple other required fields. The required fields have these asterisks next to them. Person ID, gender concept ID, year of birth. You'll see month of birth and day of birth do not, they're not required. And then you would generate, you would save your document, and then you would generate it into whatever port you wanted. If you did not want to use CDM version 5.4 for some reason, you can set your target database to one of these other target databases. That load custom one down there in the bottom is for people that want to play around and kind of sandbox their data. Maybe they're trying out a new I don't know, medical imaging table or something like that. So they could load their data into their custom format. Do we have any questions about Rabbit in a Hat tool? I know it's a very quick overview, so we're not diving down too deep, but I can take a couple questions before anybody? Yes.
What happens if you don't have some other required data fields? So like if you don't have race ethnicity and it's required?
So the question is what if you don't have race and ethnicity because it's required by the CDM? This is just letting you know and producing a document. This isn't producing your ETL. So if you don't have one of those, if you don't have race or ethnicity, the CDM documentation that Claire told you about earlier, it will tell you how to populate those fields. So for these, you're going to put in concept ID 0. You don't have any matching concept for this. You don't have data. So this is just going to give you a guideline so you can create that SQL development. You'll have to create additional things because you may not have all the source data. Yes.
Hi. Is the output of this White Rabbit parsable? I.e., is there like an XML under the hood that a developer could read to maybe emit parts of the SQL? Or is it just a graphic that you look at and you go, okay, this goes to here, I do this SQL. This goes to here, I do this SQL.
This is just a graphical interface, yeah.
Well,
you can't parse it out.
New feature request.
And the great thing about the Odyssey community is there could be a new feature request, or you could develop it at your shop and then submit it back to the Odyssey community since we're open source.
If you can generate that SQL code, there's a generate button in the menu.
Yes, so there are some unit tests that you can, let me see where it is. Right here. There is an ETL test framework that I mentioned earlier.
There's SQL skeleton files.
And then SQL skeleton files. Yes, thank you very much. So you can create your own SQL unit test.
So based on this transformation, you have to rely on
Yes, this is not a tool that will create your SQL for you. You have to have a developer. Yeah. All right, so I would like you all to, if you want to, this is the, Yes. So use the claims diag LK. Take a look at this on your white rabbit scan report. And just kind of take a look at all these different fields, the different values available, and kind of think about and work through how you might work through some of these items, right? Like here's your event source values. You can see these are probably ICD codes, but they're missing decimals. And then in your rabbit in a hat tool, once you open up the file, you can go back to the claims diag LK, and you can map it to the condition occurrence. You can open that up and actually do some rabbit in the hat mappings. So I'm going to give everybody about 5 minutes to kind of play around with it, and then come back to you all.
Fields, for example, the gender from the source table is mapped to, for example, the concept, like gender concept. On the values, how the values are mapped, for example, we have 3 values in the source, and we have 2 values in the CD, for example, 2 concept value for the how these values are mapped, for example, how do you know, for example, which value in the source we map to, for example, concept value.
Right, so that's when you're going to do is you got to download your OHDSI vocabularies from the
Yes.
Daniel noted you do need Java to run it, and if your Java version is out of date, it will not work. Just as a note. But you do not need this part to do everything else today. That's a good question. So this is just as an example. Play around with it, but everything else from here on is not dependent on this, okay?
What do you need, Java?
Okay. Yeah, so then you're just going to take the lookup of your source value. So if it's an ICD code, you signify that it's an ICD code, and it's part of the ETL and the SQL, and what the vocabulary is from, and then you look it up in the concept table, the concept relationship table, and it will know.
All this done in the rabbit, or
Which includes rabbit.
No, in your SQL. You'll have to add that into the SQL.
Yeah, but you wouldn't run quite right.
Yeah, this is just giving
That
you the
requires
table to
data,
table, field to field.
which we don't have, so they already did that work. They generated the XLSX file through White Rabbit, and that feeds into Rabbit with Hat. So you would run Rabbit with Hat instead, and load that XLSX, and then you can live it.
All right, so this is just a quick overview of that. I know it was very quick, and thank you for working with us through those technical difficulties. I just wanted to quickly mention a couple other ETL tools that are out there and available for everybody on the OHDSI GitHub. There is an Excel macros, and it helps format your White Rabbit scan report. So if you maybe have a lot of data with a lot of tables and fields, it'll create linkages from table to table and field to field. So you can quickly link between the different tabs in your White Rabbit scan report. There's a new tool called Jackalope. It's like Usagi, but it also does a little bit more for your more complex semantic mappings out there. There's an ETL tool called Perseus available. And then if you have Epic data, go out to the Epic user web, and there's a lot of information out there for you. And this is not an exhaustive list. Just by Googling or searching OMOP ETL tools, you'll find there are many papers, many repositories, everything dedicated to the OHDSI community and the OMOP CDM. And just a quick thing here on the OHDSI community resources. You know, we're an open source community, and people are very proud of the work that they produce, and there is a lot of information out there. Our forums are extremely active, and these forums right here, the CDM builders, implementers, and vocabulary forums are very useful for when you are doing your ETL. And then there's also the general forum, so go out there and introduce yourself on the Welcome to OHDSI thread, just so we get to know you a little bit better. All right, and I'm going to hand it over to Claire now.
Hands, who right now could log into an OMOP CDM instance and query against the OMOP vocabulary? Just let me know who you are. Okay, a few of us. Okay, fewer than I actually thought. Okay, so we've got a lot of newer folks here. This will actually be really helpful. And I like to walk around, so I'm just going to yell at you guys. Sorry for y'all in the front. You're just going to be like really up in your face. So the first thing we wanted to do is identify the lisinopril concept ID, because we're going to be looking at the association of angioedema with lisinopril exposure. So the first thing you would want to do is go to Athena. So everybody open up Athena. This one is an easy one, athena.odyssey.org. All right, we're going to search lisinopril. And because it's Halloween coming up in the U.S., you get a sticker or a candy if you answer my question right. Okay. What's the first thing you want to do when you see this whole big thing of lisinopril concepts? You've got 18,000 concepts to choose from. What is the first thing you want to do when you want to find the concept you're looking for lisinopril?
Class.
Class is good. Okay. Okay. Smarter for you. All right, who else had another answer?
Domain, standard concept.
Okay, yes, standard concept, very good. So Philip said class, you want to look for the ingredient class, and you want to look for a standard concept. Okay, so let's go do this over here. All right, so the first thing you want to do, you're saying, okay, I want to find everything that has lisinopril. We really want the lisinopril ingredient because using the concept ancestor table, we could find all the descendants that actually have the lisinopril ingredient. So, domain, like Philip said, we want to limit to ingredients. You want to go to class, and you want to scroll down and click ingredient. It's going to take it a second. Hopefully it's going to show up. Oh, there we go. It's working. It's trying. She's trying her best today. All right. Then when you click on ingredient, we still have 46 items, which is where Karen's answer comes in. And you want to do standard. So you want to click down concept. And you want to choose standard.
Why do some of us don't have 46? I have 34.
Yeah, I have 34 as well.
You may have less concepts because some of the vocabularies are proprietary, and proprietary vocabularies require a license. So Claire probably has access to proprietary vocabulary, so she would have more concepts.
And that is different. That's very interesting. I didn't realize that my access actually went down to Athena. So did everybody hear that? Okay, yeah, so there's licenses involved. So Athena also does this very helpful thing where it finds other concepts that have similar names to what you looked for. So it actually gave me two, lisinopril and phosinopril, but we want to choose lisinopril. So that'll be the concept ID 1308216. So everybody memorize that because you're going to be tested on it later. And then that code right there is actually the code for that ingredient in the RX norm vocabulary. So if you're going to go to RX norm, the way they identify lisinopril is that code 29046. But we call it that 1308216. So that's the one you want. All right. We've got 10 minutes. All right. All right, so we want to take that one. I think what I think would be most helpful to you guys if I showed you how to use the concept ancestor table. All right, so I think that's really where I want to stop, is show you how to use this ingredient to find all of the descendants and all the drugs that have lisinopril included in it. All right, so I'm going to take that 1308216. I'm going to copy it, and then let's see here. I've got my cheat sheet, so hopefully it'll update on here. Let's see. All right. So for those of you who do have access to a vocabulary, how would you use the concept ancestor table to look up these ingredients? What would your ancestor concept be? I got a smarty in it for you if anybody knows. What would your ancestor concept be? I told you to be tested on it. 1308216. Very good. Whoever said it. Oh, Nicole, you said it. Oh, good. Good job. Good job, Nicole. So that's what you would do. So you would look up 1308216 as your ancestor, and then everything as a descendant is going to be a drug that has that included in it. So I'm going to quick pull that up and show you how that would work. All right, so like I told you before, so I downloaded like a little vocab, and this is just my local environment. All right, so I'm going to log in here, and I'm going to do a query. All right, and I'm going to quick put this in here. So you see here, so that's going to work for a second. But what is one thing you notice that I did not do here? So when this returns, what's it going to return for you? There's a specific thing I'm thinking about. So it's going to return everything. What do you think that's going to mean? It's going to pull back what? All concepts, meaning both standard and non-standard, right? So here, you want a candy or a sticker? Oh, here you go. You get some gummy bears. Good job. So it's going to bring back everything, and so you can see here in this output here, you've got even a hydrochlorothiazide, right? So as Patrick was talking about, maybe we wouldn't want that one, so maybe we would exclude drugs that were combos, hydrochlorothiazide and lisinopril. But it is returning for you everything. So maybe what we could do is then put some clause in here that says, oh, but I only want the standard concept. So anybody know what that where clause would look like? I know Philip does. Anybody else have a thought of how we would do that? Yes?
Ancestor concept is whatever,
yes.
And then you join to the concept table to buy the descendant concept.
Yeah,
and then you S is your standard.
Very good. Here you go. Are you allergic to peanut?
I like gummy bears.
Do you really?
Pretty much addicted.
There you go. Great job. Yeah, so he's exactly right. So you would then just say, oh, where standard concept equals S on that descendant concept, and then you'd be returning for you all descendants that are standard concept. Yes?
So I know that non-standard concepts are involved in the concept relationship table, but I thought that they were not included in the concept ancestor table. Not there?
No, it will include for you everything, even non-standard concepts that have that. Unless am I wrong, Melanie? Oh, I'm wrong. So I'm wrong. My bad. I'm sorry. I was incorrect. It is actually the every standard concept. We actually, Melanie ever talked about it. Yeah, I feel like you'd be better in this. She says, yeah, I don't want to see ETL. And I'm like, oh, I don't think so I was wrong. You were right. Yeah, so it is all standard concepts. You can still put that where clause in here, and he was right. So if you wanted all standard concepts, you would say where standard concept equals S. But it should only return for you standard concept. So I apologize. I said that wrong.
Oh, no, that's here.
Oh, no, you're right. You're right. I was wrong. I'm sorry. Okay, so the last thing I wanted to do was pull up angioedema. So we can go to Athena and pull up the angioedema concept really quick. All right. Okay, so everybody get here, finding angioedema? Okay, so same kind of thing. You would want to limit on standard concept. And what's interesting though is, what do you guys notice about the first one that comes up?
the observation.
Yeah, it's an observation. So Athena's just going to return for you everything. So what you would want to do is really look here to say, okay, which one am I actually looking for? And the top one might not always be the one that you want in terms of, so we know that angioedema is a condition. So we want to choose the second one. That one looks like it might be a little bit better because it's that one word, angioedema, and it's a condition domain. All right, so I'm pulling it up just so you guys can see how the concept comes up in Athena here. So like you saw, there are a lot of different options. What you would want to do, like as you're choosing your concepts, you might want to say, oh, is this the one that I want? And as you go down, I'm just going to scroll down, it has a lot of information about this concept. Hopefully yeah, here we go. So down here in the subsumes, you can see all of the descendants of this one concept. So if you wanted all angioedema, you can say, well, let me just look really quickly and see what the descendants are, and then maybe this is the one that I want. And for me, I would probably choose this one and take all descendants of this concept, since it seems like it has a lot of different things related to angioedema underneath of this hierarchy. And then you could do the same thing where you say, select from concept, join to concept ancestor, where the ancestor concept is this guy.
What, like a like statement?
You would do so we would do the same thing that we did before. So if we go back here. All right, so it's taking it a second, but we would just use the same query we used before, but now it's going to return for us all conditions that are underneath of that angioedema condition. Yes?
So I'm kind of confused why you need to do the second step. The first step, you find a common ID for that drug or for the disease condition, right? Then you know, okay, that's the ID I need to use. But what's the purpose of doing this one?
Well, so in terms of drugs, you're not just going to get a prescription that says, here, you're going to get the lisinopril ingredient, and you figure out the dosage and how much you should take every day, and all that kind of stuff. So what we're trying to do is use the vocabularies as a hierarchy to identify for us all those different forms and ways that you might see lisinopril in your database. So that way what you do is you get this list of concepts that will say, well, these are all the ways that lisinopril could potentially be represented in a standard way. So you don't have to figure out this list. You don't have to go through with a fine-tooth comb and say, oh, I see the word lisinopril, I'm going to take that and I'm going to put that in my list. Now you can use this functionality in the hierarchy to say, okay, it's already done for me. I know I want lisinopril. I don't want maybe hydrochlorothiazide, so maybe I exclude those drugs that were a combo, hydrochlorothiazide and lisinopril. But now I have this entire list of concepts that I can then go to my drug exposure table and say, okay, give me everything where I have a record of one of these concepts, and now with just these two steps, you found every single record of lisinopril in every way that it's represented in your database.
So you have to go through the two steps, the first one and this one, in order to find the corresponding concept.
Yes, you do, but this is if you're going to do it manually. So you'll see an example in Atlas where Atlas will do this automatically for you. So in Atlas, there's also a vocabulary explorer. What you would do is you choose, oh, lisinopril, I'm going to create a concept set, and then I'm going to find everybody who has that concept in that concept set. So this is really as an example of if you wanted to do this manually to explore the vocabulary, this is how you would do it. But really, if you're going to use Atlas, Atlas will kind of package all this up for you and do it for you. Mm-hmm.
Claire?
Oh, yes.
Oh, sorry.
No, go ahead.
When you're looking at something like angioedema, there were several concepts. In Athena, especially if you're going to go for all descendants, would you recommend going in Athena and clicking on angioedema and looking at the hierarchy, maybe seeing what's above angioedema and seeing if that's the real one you want to start with?
Yeah, you could definitely do that. I often like to do that in Atlas. It's just your preferred tool. So he's asking about the hierarchy. In Atlas, there's a nice functionality where you can click through, like, go up one level, go down one level, and then you can kind of figure out which is the exact concept I want. Because in the one we were looking at, like, maybe, you know, maybe I do want this ACE inhibitor aggravated edema, right? Because we're looking at angioedema associated with ACE inhibitors, but maybe I don't want venom-induced angioedema. And so you want to work through your concept set to figure out how do I exclude those. Maybe they're a common ancestor that I could exclude to get rid of these ones that are not related to ACE exposure. But yeah, so it's a good question. You can visually look at the hierarchy in Athena, and it's really just your preferred tool. Oh, I want to hear the first one. Yes.
A really basic question, but how do you get the CDM into your Postgres?
Oh, that's actually a pretty good question. So the question is, how do you get the CDM into your Postgres environment? There's a couple different ways you can do it. If you are so inclined, I recommend the ETL Cynthia repository. I know I have a break, but really quick. Let's see. Let's see if I have it up here. Sometimes I have it up here. ETL Cynthia.
And GitHub really does have everything.
Yeah, so if you want just like a synthetic data set to work with, ETL Cynthia has done all of it for you. So this is maintained by Frank DeFalco. Thank you. Goodbye. This is maintained by Frank DeFalco and Anthony Molinaro. It's super helpful if you just want a local environment, a local instance of a CDM to work with. It has all of it here for you. All you would need to do, and it details how to do it, but you would download some Cynthia data, which is a synthetic data set, and it'll actually run the whole ETL and set up the CDM in your environment for you. So really simple. That's what I use just to do some local development. Very helpful if you just want to play around with some data. Yes?
The question is, so here we have one drug or one condition. Like, if you want to do ETL for the parametrics or microscale, then you have millions of the different drugs and conditions. You have to do like this.
Okay, so the question is, right now we're just looking at one drug, one condition. What happens in like parametrics when you have millions of drugs? How do you do this at scale? How do you map this at scale? That was that query I showed you earlier. It was like the source to standard query. So what you would do is you run that query and you say, oh, I know my drugs are in NBC, for example. So you could just run that query and essentially link up those mappings to the NBC codes in your data set. We know Pharmetrics is a US database. It's going to have NBCs. So what that query will do is just tell you, for this NBC, this is the standard concept. And the standard concept is going to be one of those descendants we found of lisinopril. Does that make sense? Okay. Yes?
Quick question. Is, if you look up the ancestor for an OHDSI concept, is it going to be in the same vocabulary, or do you have to constrain your query to force it to just look up in that vocabulary?
You don't need to look up in the same vocabulary. I wouldn't constrain it to the vocabulary. I would just look at what are the ancestors for this
So
concept.
it could be in a variety of different vocabularies.
It shouldn't be. I mean,
yeah,
it could
ABCs,
be. Yeah, that's true. Yeah,
classification.
classification. So it could be.
Okay.
But I wouldn't limit it to just one vocabulary, because it's really kind of all been done behind the scenes. So any ancestors you get, it should be relatively straightforward how to use that.
Okay, thank you.
I'm not familiar with the Phoebe tool, but does that explore the hierarchies as well?
I don't. Does it?
Yep.
Okay.
And it has labels. If you have questions, now's a great time to go find a collaborator.
So we only have 5 minutes until the next session, so I do want to give you guys an energy break. Thank you for sticking with us and letting us figuring out our bumps and understanding as we kind of run around. So I appreciate it.
And just Thank you, Claire and Melanie.